Anybody stuck or we're progressing? Probably you will need to first find moles before you can find atoms.
Solving for atoms and writing down the mole step in the middle.
Yeah. Okay. Get those answers? Emily? You didn't get the first one? Did you not solve for the first one? Okay, so that would just be taking, instead of doing it a two-step problem, do it in two separate steps. Because grams to moles, that's molar mass. Molar mass, what's the molar mass of aluminum? Oh, you have to figure it out. You just didn't solve for the first one. What is it?
25.9.
26.98.
Say, I thought it was 26.
26.98.
You got very good eyesight?
It was tough to see.
You can see that?
You don't
Not
have
really easily, but yeah, I see.
You don't
Sorry.
have you don't have your little one?
Oh, yeah, I just didn't pull it more.
Okay, so then this would just be Avogadro's number, correct? Okay, again, I'm expecting or assuming that this is coming back relatively quickly.
Yeah.
So it is your job to say, hold up, how'd you do that if you don't understand? Okay? I'm gonna assume you guys are getting everything unless you stop me, and there's nothing wrong with stopping me. I just don't want to waste time on things I don't need to waste time on. Okay?
Stop.
Okay. Next one. This one is just like the previous one, except for one additional pre-step. I'll let you guys do this, and then I'll just give you the answers, and we'll move on. Essentially what we're computing here is, if we know the mass, we can figure out how many atoms. If we know how many atoms we have, we can figure out the mass, the moles, all those things through math. What is the only thing that's different about this one?
Yeah, get it to grams.
Yep, convert to grams. And she said yesterday, after I was reaming all the freshmen or scaring them to death about the quiz today, I said, all right, you guys all probably are scared of me now, I'm sorry. And she goes, no, I love this class. And I was like, all right, thanks, that's good.
Wait, have you heard her sing before? Yeah. I think she's good. Yeah, she sings really well. Yeah. That's one of the try.
Everybody get that for molten silicon?
I didn't ask.
Didn't?
It asks for atoms.
Oh, never mind. We'll go one step further. And you should get what, 1.22 times 10 to the 20th silicon atoms. Yes? Everybody?
Did you get 2.0?
Somehow I got 1.621. Oh, I rounded up.
What?
Never mind. I put 21.09.
What was that, Nathaniel?
I think I'm just typing it in now, because I have 5.68 times 10 to the negative. But then
You divided by this,
Yeah.
and you multiplied by this?
Well, I'm wondering how you got the 2.02 times 10 to the
I just solved after I divided by this. You didn't need to solve for that. This is the correct answer. But, did you write your work down? Yeah.
But I changed my answer, but I think it's just a calculation. Is there any
Probably.
This?
Oh, every time you're in scientific notation, you should have parentheses. Every single time. Is there a next one that's before we get to the next section? How much you working on that? Did you figure it out, thing?
No, every time I do that, I get.
Did I write it up there wrong?
I don't get that. I get 1.44. I've looked at it many times.
I get.
And you get a 1.22.
I got 1.22.
I didn't look like I wrote it up there correctly.
5.68 divided by
21 is not the right. This is should be 28. That's why. I don't know why.
that changed.
Oh, yeah, that's showing you're dividing the exponent by that. It should be below it. I don't know how to. So this was 5.68 times 10 to the power of 3 over. That brings the parentheses down. See what I just did? Yeah, that one divided by. You wouldn't have to do it in this context. It wouldn't hurt. There's a 2.02 times 10 to the negative 4 is what I have up there. Times, parentheses again, 6.022 times 10 to the power of 23 over arrow, parentheses.
Thank you.
So we're on the cobalt one. Doing good. I think the cobalt one is going the opposite direction, is that correct?
Yeah.
So the other ones we started with mass and went to atoms. This one is going the opposite direction, taking atoms and going to mass. both numbers, doesn't it? What's moles and mass?
Yeah.
You just have to, instead of doing bridge notation where you're doing both at the same time, just do one answer, do the other answer.
Or your bridge notation, just stop in the middle.
What?
Or your bridge notation, just stop in the middle.
That's the same thing as what I said.
Oh, sorry.
Alright, what's your different mole number?
8.3 times 10 to the negative 4.
Yep. And then moles to mass using what?
Multiplied by the atomic mass. I'm sorry, not the, yeah.
Molar mass.
Molar mass, yeah. Good math. But it's the same number, just different unit, so.
Get it?
You get 0.049 or
When
4.9.
you do that, what is 1 mole of cobalt? That I do not know off the top of my head.
58.93. You get 4.9 times 10 to the negative 6.
So moles and AMU are the same thing.
Why? It's the same number than units. One is the
Yeah.
size.
Same number, yes. It is the same number, but it's a different unit. AMU is an extremely small unit used to figure out the mass of lone atoms or lone particles. Molar mass is the unit, or moles is the unit that we use for figuring out grams. Alright, everybody get that number? I don't know, I assume that's the right number. 4.89 technically just sig figs.
You're right.
I just had it to the
I didn't say you
negative
were wrong. I said it because I wanted to.
Alright, let's move on. We got 3 more problems left. I think 12 minutes, we should be able to get those through. We're gonna take a little bit of a break and just review. You guys used molar mass to do these problems, but you only did the molar mass of an individual atom. You never were asked to do the molar mass or use the molar mass of a compound. Okay, and I don't think you guys will take, I don't think it'll be too difficult for you guys to remember how to do the molar mass of a compound, but just in case, let's say I got CH4. You might remember how you figure out the molar mass when you've got more than one kind of atom.
4.04 plus 12.
Yeah.
4 times hydrogen, which is 1.01, plus 1 times 12.01. Yes? So you guys all knew that? Didn't need to refresh us in any way? Okay? Alright, let's move on then. I'm going to assume you guys got that unless you stop me.
For oxygen, you just assume 16, or if you're right at 15.99.
It should round, if you always round to the second decimal
Yeah, so it
place.
is 16.
So yes, it would be 16.
Or should it be 4.89?
Oh man, that doesn't leave me any space to write, does it? Jugal, I don't know if that's how you say that. A dye known for centuries here. Guess I didn't know it. Is also a natural herbicide, a weed killer. Kills off competitive plants around the black walnut tree. There's your formula, C10H6O3. First calculate molar mass, then use it to figure out how many moles of a sample of a particular mass. Feel good about this that you could do it without my help? There's not a lot of space there, is there?
Well, right above it.
Oops, that's odd. Sorry guys, quite small. Molar mass, we got it? What is it,
74.
174.16. Don't know why I'm trying 174.1. Did I do that wrong? No, it's 16.
I mean, maybe.
You guys got it, same thing?
Yeah.
Okay. I don't know why I did that. Right. Now, how would I write the units for this?
Grams of.
Or, that's very important, that's the technical correct unit, it's not grams. I know a lot of times I omit the 1 mole underneath here.
Oh,
Okay.
yeah.
But, and yes, we're canceling out the moles of carbon, but this is per mole of the whole thing, so that's why that mole is still in there. And then you guys are probably already done with the other one too, or are you still working? Okay, why don't you guys do B then? Same process as what was before, now you're just using the bigger molar mass number because of the bigger compound. How can I abbreviate this?
That's times 10 of
Is it? Yeah, it is. You are right.
That's JR2.
What'd you say?
It's a barrel wheel.
I would give out so much candy if I if I said that. Does he not make hardly any mistakes?
Nah, he does.
No, he just. I mean, I like the idea that like you're looking for things I'm doing wrong and you're not scared to say it. What I should do is if you correct me and you're wrong, then you should give me candy. So then you want to.
People never want to ask
So
to
you
see.
can just buy a cheat from the Amish.
Right. Brian does run a lot. He'll like, when you do it all, like, oh wait, no, you do it. Yes, Ryan's always on top of things. He's always checking, because he's always checking before anyone else.
What? Did I do something wrong?
Yeah, because it always a good thing.
Did you flip this?
Then that means I just didn't try for it, so I just didn't think about it.
Were you just going slow or did you know what you're doing? .96 times 10 to the.
Negative.
So is this part here the same as what we did the previous problems ago? The only difference is we had a bigger mass because we're dealing with a much bigger molecule. In fact, we're dealing with an actual molecule instead of just a lone atom. Yeah. All right, I do want to make sure that we get to the last two. So we're going to work through, let me think here. I don't know why I just don't save it like this, so I have room. Let me just look at this one. If this one's just like the previous one, I want to make sure I do the next one because that's a little different. Oh, this one is important too. Okay, let's work through this one together just for the sake of time. I want to get through both of these because there is a little subtlety. You're going to start seeing what the next kind of step that we would have never have done in regular chemistry, but now we're asking you to do here in this.
Calcium carbonate.
So we got calcium carbonate. That's the guy we're dealing with. I'm going to ignore all the introduction, calculate the molar mass. That's going to be pretty easy. Can I just give that to you since you guys are all good with that?
Yeah.
Okay, so the molar mass of this guy is 100.09 grams per mole. I really want to focus on B because it takes us a step further. A certain sample of calcium carbonate contains 4.86 moles. So this is a little different from the previous problem because we're starting with moles now instead of mass. And it wants us to figure out the mass. And remember, this is calcium carbonate. How many moles of calcium carbonate I have? We know the molar mass. so we can figure out the mass from that, correct? We know that we got 100 for every 1 gram, so we should have what, a little less than 500 here? I'm assuming, just looking at it visually.
I read the part you
I think from a sig fig standpoint, this is 486. So if I have 4.86 moles of calcium carbonate, I know that I have 486 grams of it. Now the second part of this is what I want to focus most on because it's a little bit new. It is what is the mass of the carbonate ions present. There's a couple ways to do this. I think there's one way that's the easiest. Okay, here is my whole formula unit here. That is the whole thing. So this is the mass of all of it. Yep. Okay, and we figured it from the moles of all of it. Okay, if we can just find out how many moles of CO3 we have, could we do essentially the same thing? Okay. Is there a connection that we can make? Remember the sandwich example?
So we can't do proportion and subtract that.
You could, but that would take, I think that would take longer.
Okay.
Right? If you want to do that,
Yeah.
you can.
All right.
Okay, if I look at this, I have 4.86 moles of the whole thing. That's the whole sandwich. How many moles of CO3 do we have? How many of these do I have in this? I have 1. So if I have 4.86 moles of the whole thing, I have 4.86 moles of CO3 as well. If this were 2, then I would know it would be breaking up into 2 times the amount of particles as the whole. If there were 3 of these, it would be 3 times, and so forth. Does that make sense? Okay? So I know I have 4.86 moles of CO3. 2 minus technically.
291. Proportions.
Okay. You see the proportion?
Yes.
You might be faster. I really wanted to teach this connection
Oh,
here, though.
sorry.
Okay. You might be right. It probably is faster. We could do this a couple ways. We could just quickly find the molar mass of this, or we could subtract calcium from the molar mass of the whole thing.
I decided.
Yep. And so that should be like 60.01.
Yep.
And then you should be able to multiply that and get your 292. Grams of my ions. Now, you can use the proportion. That is fine.
I think it's 92. It's 91.9.
I don't know. I mean, it's pretty similar. I wouldn't worry about that.
Yeah.
Okay. Shoot, I really wanted to do that as well. I really wanted to just focus on this relationship because later on when we do solution chemistry, you'll have to be able to do that over and over and over and over again. This next problem, I want to spend a little bit of time at least talking about how you can set this up. Okay. It says that we got a certain amount of mass of that compound. Okay. The resulting center tract D, blah blah. How many molecules of it do I have? But then what does it say? How many atoms of carbon are in that molecule? All right. So you would take your 1 times 10 to the 6th. You would take that, and using your molar mass, you would figure out how many moles you have. I'll just give you the number here. 8 times 10 to the negative 9 moles of my thing.
Oh, I really like how these snacks also.
Could I then take that and figure out how many molecules I have?
Yeah.
How would I do that? Avogadro's number, right? Okay. So I'd do another conversion to figure out molecules. and it's 5 times 10 to the 15 molecules. So that would answer that question, yes? Okay, just going through it fast because you'll probably see one of these in your homework, and I want to give you a quick little synopsis. Now, the harder part of this is determining how many atoms are present in that many, how many carbon atoms are present in that many molecules. Any ideas?
You won't talk about 7. There's 7 around.
Okay, we know that every one molecule contains how many carbons?
Oh, the mems.
Okay, remember the sandwich? One sandwich, but many pieces. Remember that? Many parts. That's a C for carbon atoms, so 7 carbon atoms. Everybody see how for every one molecule, I've got 7 carbon atoms and how that works? So I figure out how many molecules of this I had, and then I know the relationship between molecules and carbon atoms that I can finish. Okay? You can leave. Sorry to keep you a little late. I just wanted you to at least see that for your homework. Okay? I might have lingered on the easy stuff a little too long. 120. Chemistry students, you can come in.